This is a lesson on proportions. We've already learned that ratio tables can be used to find proportional amounts. For example, a recipe for salad dressing calls for mixing 6 tablespoons of oil to 2 tablespoons of vinegar. How many tablespoons of oil should you mix with 6 tablespoons of vinegar? So we're comparing oil to vinegar, and we're told that the recipe is 6 tablespoons of oil to 2 tablespoons of vinegar. And what we're changing is we're changing the fact that we have 6 tablespoons of vinegar. And we want to know how much oil do we need. So we've learned that we can easily find this by using a scale factor. The 2 times 3 will give us the 6 vinegar. Use the same scale factor on the oil, 6 times 3, and we get 18 tablespoons of oil. We can also convert our ratio table into what we call a proportion by taking away the walls. So instead of actually drawing the ratio tables, we kind of draw it without walls, and we put in an equal sign. There are actually 3 parts, 3 different ratios. The first one is what I call the label ratio. It's very important to include labels when you're setting up proportions, because we need to make sure that the numerator part of our ratios represent the same thing. In this example, they need to represent oil. And make sure that the denominator values represent the vinegar. We don't want to switch it up and have the first ratio be oil to vinegar and the second ratio be vinegar to oil, because then it wouldn't be proportional. It has to be the same order. Remember that a proportion is a mathematical equation stating that 2 ratios or rates are equivalent. And equivalent means that they're equal, that they're proportional. 2 to 5 is equal to 6 to 15. And we've already learned how to determine this. You could simplify it. You could find a scale factor. But this equal sign is stating that these are for sure equal. $2 for 10 prints is proportional or equal to $6 for 30 prints. When 2 ratios or rates are proportional, we can use proportions to find the missing value. And there are 2 methods. The first one is to simplify or find the unit rates. And the second method is to use a scale factor. So we're going to go ahead and start some examples by using method 1, simplifying or using the scale factor. Francine earns $400 for 40 hours of work. How much will she earn for 6 hours of work? Okay, we're going to write 3 different ratios. The first ratio is the label ratio. What is it that we're comparing? We're comparing money to hours of work. So that's going to be our ratio. Money, dollars, money. And remember, money is almost always going to be your numerator. And time, which is the 6 hours, or the hours, will usually always be the denominator. So the second ratio, or rate, is going to be what we're given. We're given $400 for 40 hours. So the money goes in the numerator. That's what the label ratio tells us. So the 400 goes in the numerator, the hours goes in the denominator, and it's 40 hours. Then this third ratio is going to be our wanted proportional, what we're changing. Okay, we're changing to 6 hours, so we're going from 40 hours to 6 hours. So the 6 goes in the denominator because that's what the label ratio says. And it's the dollar amount that we're looking for. We want to keep this proportional or equal, so we put our equal sign. Now we're going to use a little bit of algebra. Sometimes you'll see a question mark, sometimes you'll see a box, but we're going to use a little bit of algebra. I'm sure you've heard of the term variable. Maybe you have some older siblings or relatives who have taken algebra, or maybe they're taking high school algebra right now, and there's variables. Variables are just letters that and they represent unknown amounts. The most common variable is an X, but it could be any letter. And I'm going to go ahead and use the letter N, because N is going to represent a number. Okay, so this is some number that we want to solve for. And now we solve. We're going to simplify or use a scale factor. I'm sorry, this actually should not say scale factor. This should say unit rate. Sorry about that. Simplify or find the unit rate. We could find out how much for 1, or we could just simplify. I'm actually going to go with simplifying first because I can see that they both end in a 0. And remember our little shortcut trick? If the number in the numerator and the number in the denominator both end in a 0, you can cross them out. And that's the same as dividing by 10. And that leaves us a 40:4 ratio. I can divide by 4 and find my unit rate. 40 divided by 4 gives me 10. And 4 divided by 4 gives me 1. So I have a unit rate of 10:1. I'm going to cross out this ratio because I'm now using the 10:1 ratio. Now that I've found the unit rate, I can easily use my scale factor and go from 1 to 6 by multiplying by 6. Do the same thing to the 10. 10 times 6 will give us 60. So this n value, this unknown number, is 60, which means that she can make $60 for 6 hours. Okay, the next one. Mr. Abdullah's new car, that should say car, can travel 360 miles on a 12-gallon tank of gas. How many miles can he travel on 8 gallons? What are we comparing? We're comparing miles to gallons of gas. So let's set up our label ratio. It doesn't matter in this case whether you put the miles in the numerator or the denominator, but you need to make sure that it stays the same for all of your ratios. I'm going to do miles to gallons. My given ratio is 360 miles, so that's going to go in the numerator to 12 gallons of gas. And the gallons of gas is going to go in the denominator. And we're going to make this equal because we want to keep it proportional to our new rate. And on our new rate, we need 8 gallons of gas. The gallons goes on the bottom. So the unknown is the number of miles. That's going to be our variable n. This I can see that I can find the unit rate by dividing. I know that I can divide by 12. 360 divided by 12 is going to give me 30. 12 divided by 12 will give me a 1. So I'm going to cross out, and now I can use the scale factor. 1 times 8 will give me 8, so I multiply 30 times 8, and my unknown amount is going to be 240. So he can drive 240 miles on 8 gallons of gas. Excuse me. Okay, method 2 is using the scale factor. Belinda runs 8 kilometers in 60 minutes. At this rate, how long would it take her to run 2 kilometers? We're going to do the same thing. Okay, label ratio. What are we comparing? We're comparing kilometers to minutes. So time usually always goes on the denominator, so this will be the minutes, which means the kilometers will be our numerator. The given ratio is 8 kilometers to 60 minutes. Make sure the kilometer number goes on the top. And what are we changing? We're changing to 2 kilometers. So we're going from 8 kilometers to 2 kilometers, and what's missing, our unknown, our n, is going to be the number of minutes. And you can see we can go from the known to the unknown, from 8 to 2 by dividing by 4. So we do the same thing here, divide 60 by 4, and our n is going to equal 15. So at this rate, how long would it take her to run 2 kilometers? The answer would be 15 minutes. To make 5 blueberry pies, Mindy needs 2 pounds of blueberries. How many pounds of blueberries does she need to make 20 pies? So what are we comparing? We're comparing the number of pies to the pounds of blueberries. So my label ratio is going to be pies, and I'm going to put a BB for blueberries. What rate or ratio are we given? 5 pies, so that goes in the numerator because the label ratio says so, to 2 pounds of blueberries. So the 2 will go in the denominator because the label ratio says the blueberry goes in the denominator. We'll make it equal to another rate. We're going to make it proportional. And what do we want in the second rate? We want 20 pies. Pies are in the numerator, so the 20 goes here. Our unknown, our n, goes in the denominator. Do you see the scale factor? Sure. 5 times 4 will give you 20. So multiply 2 times 4 and you get 8. So how many pounds of blueberries does she need? 8 pounds of blueberries. Sometimes you're going to have to combine the two methods to solve a proportion. If there are 1,200 calories in 8 ounces of hot fudge, how many calories are in 6 ounces of hot fudge? So we're comparing calories to ounces of hot fudge. So that's our label ratio. Calories, and I'm just going to put cal, to ounces. What's our given amount, our given ratio? 1,200 calories, that will go in the numerator, to 8 ounces of fudge. That goes in the denominator because that's what our label ratio says. And we're going to make an equivalent ratio, and we know in our equivalent ratio we need 6 ounces of hot fudge. So the ounces are in the denominator, 6 goes in the denominator. Our unknown is the number of calories. Can't use a scale factor, cannot go from 8 to 6, but we can definitely simplify. Could divide both by 4. When I divide by 4, I get 300. When I divide 8 by 4, I get 2. So I'm going to cross out my old and use my new. So here I'm going to go from 2 to 6, scale factors times 3, and I'm going to do 300 times 3, which is going to give us 900. So how many calories are in 6 ounces of hot fudge? 900 calories. So on this one, we couldn't just use scale factor alone. We had to simplify first and then use the scale factor. And this happens a lot. Okay, I think you're ready for your independent practice.